everyone, it's Math with AUB. Let me continue in the field of domain and range. To find domain of a function, I have repeated several times, for real valued function we cannot afford overall negative square root. Overall negative square root we cannot afford, number one. Number two, denominator does not cease to exist and log is defined for positive values. Let's move. Our question number one is f of x is equal to x plus 1 times x minus 3 divided by x minus 2 overall radical. In that case, f of x, we have x plus 1 times x minus 3 divided by x minus 2. Now here is denominator as well as square root. Denominator as well as square root. First we settle down denominator. I can write this x plus 1, x minus 3 dividing and multiplying by x minus 2. Dividing and multiplying by x minus 2. We have something like that, square root x plus 1, then x minus 2, then x minus 3. There is a pair of x minus 2. By doing this, we got rid of x is equal to is our restriction. The value x is equal to is the value where denominator ceases to exist. If denominator is present in square root, then it is a cumbersome. Then we have to calculate or look for whether it is positive or negative. By doing so, getting rid of this square root by simply dividing and multiplying by x minus 2, we have settled down the denominator. X does not equal to 2. At x is equal to, the denominator vanishes. At x is equal to, the denominator vanishes, and the division by 0 is not allowed in mathematics. The rest is Swift concept. For a square root, they must be greater than or equal to 0. It gives us x is greater than minus 1. For this, it is x is minus 2 greater than or 0. It means x is greater than 2. For last one, x minus 3 greater than or equal to 0, it gives x is equal to 3. Let's plot them on the real line, then finding the portion where this function doesn't be negative or 0. Real line 0, minus 1, minus 2, positive 1, 2, 3 and so on. For this, including x is equal to minus 1, greater than minus 1 means towards right hand side. Similarly, here x minus 2 greater than or equal to 0, minus 2. We cannot take 2 because x is equal to is our restriction. X does not equal to s. Now checking which one is our interval that satisfied our this function. This function can also be written as x plus 1, x minus 2, x minus 3 overall square root divided by x minus 2. Okay. Checking from minus 1 to 2, minus 1 to 2. If I put 0 here, it give me what? Let's see and find out. It will become 0 plus 1, 1, 0 minus 2, minus 2, 0 minus 3, it is minus 3 divided by minus 2. Look at the square root, negative, negative, positive. It will become 6 divided by minus 2. It's a real valued function. It's okay. If I take 1, also check 1, it will give me 1 and 1, 2. It will give me minus 1. It will give me minus 2 overall divided by 1 minus 2, it's minus 1. Minus plus, it will become 2 divided by minus 1, minus 2. It is also defined. So this vicinity to be taken, except minus 2. So minus 1 is less than or equal to x is less than 2. This portion must be included because it gives us a real valued function in the square root. What about this interval? At x is equal to, the function ceases to exist, denominator is 0. The function ceases to exist, denominator does not exist in that case when x is equal to. Between these two, if I take 2.5 to be checked, let's see and find out. It will give me 2.5, it will give me 0.5. What about this? It will give me putting 2.5, negative 0.05. Minus minus plus, in square root if it gives me negative values, so we have to discard this portion, not to be taken, and x is greater than 3, it's safe to be taken. Why? Put x is equal to 3 or greater than 3. If x is equal to 3, it is overall 0 is real valued function. If I take 4, it is positive, it is also positive. Denominator does not make sense whether it is positive or negative, it's okay. We have to check denominator. So it is safe to check that one, to take x greater than or equal to 3. Now reconcile all these facts from minus 1 to 2 excluding 2, minus 1 including, x is equal to excluding. So I can write this semi-closed interval minus 1 to 2 union. Between 2 to 3 we have to discard these values because they give us negative values in square root. Then from we can afford 3 towards right hand side, that is our domain for this function, What I have done here, to check square root of numerator as well as denominator, it is cumbersome, it gives you a little bit difficulty. In order to save our soul, I have divided and multiplied by x minus 2. X minus 2 is outside the square root. Now I have single headache. I have to check square root of x plus 1, x minus 2, x minus 3, it is in numerator. I have checked them. For denominator, I have just discard x is equal to, because at x is equal to, the denominator ceases to exist. For this x plus 1, I have taken x is greater than 1. X plus 1 is greater than or equal to 0, it means x is greater than or equal to minus 1. Later, x minus 2 is greater than or equal to 2, it is x is greater than or equal to. But taking care of denominator, I surrender x is equal to. Then for x minus 3 greater than 0, I have taken x is greater than 3. Then I have checked from minus 1 to open 2 excluding 2, all these give real valued function in the square root. Good. Between at x is equal to, the denominator ceases to exist because the denominator is going to be 0. Between 2 to 3, it gave me negative values in square root. I have discarded them. Then from 3 onwards, including 3, at x is equal to 3, the denominator is going to be 0. So our domain is minus 1 to 2, semi-closed, minus 1 including, 2 excluding. Then from 3 towards right hand side, keep on going, it will give us a real valued function. Moving towards next question, we have